day, and welcome to the AASHTOWare Pavement MED Design webinar number 3 for this fiscal year. Our topic today is Composite Pavement Design and the AASHTOWare Pavement MED Design software. Next slide, please. I'm Clark Morrison, Pavement Design Engineer with the North Carolina Department of Transportation and Chair of the AASHTOWare Pavement MED Design Task Force. Our co-chair is Hari Nair of the Virginia Department of Transportation. Presenters today will be Wouter Brink and Harold Von Quintus of ARA. The presentation will be available for viewing on the MED Design Resource website following this broadcast, and the website is on the screen now. Next screen, please, or next slide. The AASHTOWare Pavement MED Design Task Force provides guidance and oversight for the maintenance, support, and enhancement of the Pavement MED Design software. Other members include Ryan Fragapane, who is our AASHTO Project Manager, again, Hari Nair of Virginia DOT, our Vice Chair, Patrick Birrell with Ohio DOT, Suzanne Chan of the Ontario Ministry of Transportation is our liaison to the Transportation Association of Canada, Kumar Dave with Indiana DOT, Felix Doucette of the Quebec Ministry of Transportation, Dulce Feldman of California DOT, Ian Risch with Georgia DOT, and Tom Yu of Federal Highway Administration is our FHWA liaison. Now just a few brief housekeeping issues. Your phones are being muted. Please post your questions in the Q&A box, and this can be accessed by clicking on the WebEx Q&A button. The presenters will answer all questions at the end of the webinar as time permits, and questions that are not answered during the webinar will be responded to separately. And I think to start us off, Wouter, we'll go to a poll question.
Yes, Heidi, I think you should be able to open the poll.
Wouter, do I need to stop sharing my screen?
Heidi, I'm not sure. Rob, I don't know, Heidi. Yeah, I don't have access to the polling part right now.
Yeah, I can't activate them. I think it's on Harold.
Okay. Yeah.
Okay, I stopped sharing my screen.
Heidi, you can make me presenter, and then I can just run them, unless you have them open. Heidi, can you either make me presenter? All right, there we go. All right, sorry for that.
Sorry, I tried. They didn't show up.
It's okay. Harold, do you just want me to share while we're here?
Yes.
Okay.
And I'll just have you also share the presentation.
Yep, that's what I was thinking. And it's the one I just downloaded, what you sent yesterday, so. Can y'all see my screen?
I see the poll.
Oh, okay.
The questions. I see the questions.
Okay. Share PowerPoint. Get the polling up. Okay, I'm going to go ahead and there's still a minute left in the poll, but it's like
yeah, those were simple questions. So
yeah.
if most have answered, then let's go ahead.
You have about 50 out of the 89 have completed.
Okay.
All right, I'm going to go ahead and close this poll.
Okay.
Okay. All right.
Okay.
Yeah, I think
We
continue.
ready to go, Booter?
Yeah, I think so.
Okay. Okay, I'm going to go ahead and start then, and Booter, you'll drive the slides.
Yep.
So as Clark said, welcome everyone to webinar number 3. The prerequisites for this webinar is prior experience with both new and rehabilitation design, flexible and rigid pavements, as we have for the previous 2 webinars this current fiscal year. I'll go to the next slide, Victor. There are basically 4 learning outcomes for this webinar. First one is we're going to define new composite pavements for use as a new design strategy using the PMED software. Second one is to list and explain some of the assumptions for the new composite pavement designs using the software. Third is identifying some of the inputs that are needed to simulate new composite pavements. And then the fourth, and probably more important one, is describe some of the main engineering points that engineers should consider in designing new composite pavements. Go to the next one slide, Gooder. So we're going to start, first of all, with the definition, new composite pavements. Go to the next one. Many agencies that use the PMED software define composite pavements basically as an asphalt overlay of a rigid pavement. And if you would forward, Booter. And that's really not the definition that we're talking about in terms of this webinar. The webinar content and or focus of this webinar is for new asphalt layers as well as new PCC layers placed over recently placed PCC layers as a type of composite pavement. So we're talking about new pavements and not rehabilitation of rigid pavements. Go to the next one. So if we look into the pavement, the MEPDG Manual of Practice under Section 3.3, under the subsection semi-rigid pavements, the Manual of Practice says this type of pavement, which is semi-rigid, is also referred to as composite pavements in the MEPDG manual of practice. This was the initial version of the manual of practice that was published back in 2008 itself. Go to the next slide, Wouter. Under section 3.4 of the MEPDG manual of practice, under the topic JPCP overlays, the manual of practice states, composite pavements consist of AC placed over PCC lean concrete or a cement stabilized base, which would include roller compacted concrete. Composite pavements are the same as semi-rigid pavements defined in subsection 3.3 that was listed on the previous slide that we just showed. So, Wouter, go to the next one. So those were the definitions for composite, or really the manual of practice defined semi-rigid pavements and new composite pavements, as well as rehabilitation as one in the same. The Sharp 2 work that was done and reported in 2013, there were 2 reports that were published, defined composite pavements differently. And these composite pavements, and these are the 2 references for this webinar itself also. There was a volume 1, and volume 1 was specifically HMA over PCC for both new pavements. New HMA placed on recently placed PCC. Volume 2 was for PCC, or new PCC, placed over new PCC, also as a composite pavement, or in other words, a 2 lift placed Portland cement concrete pavement. There a lot of words are on the slides. These are, or this slide, this is the basic the 2 references for the webinar. And we put these references in for users to go back to this webinar for these references into the future. So there's a reference there. I'd also like to note and give kudos to my daughter, who I think is on this webinar, Julie Vanderbosch, who also I think registered for the webinar, and Sri Rao, and I'm not, who I think registered for the webinar. I'm not sure if Lev Kavanovich or some of the other authors have registered for the webinar or not, but there are some of the authors for volume 1 and 2 of the Sharp 2 work that are listening in on this webinar, and I'd like to have them feel free to correct anything I may say that wasn't directly in conformance with the 2 volumes of the Sharp 2 research. So saying that, if you'd go to the next one, Wouter. The definitions now in those 2 Sharp 2 research reports. First of all, starting with volume 1, HMA over new PCC composite pavements. This is defined as and this comes directly from the Sharp 2 volume 1 research report. And this is a relatively thin HMA layer placed, it could be 1 lift or 2 lifts, multiple lifts, over a newly placed but sufficiently hardened PCC layer. And the other thing I'd like to note within this definition in the volume 1 report is also shown in red in italics in the lower part of the definition. The PCC layer can consist of jointed plank concrete or continuously reinforced concrete mixes or layers. It's also noted that this lift or the lower PCC layer can consist of roller compacted concrete, lean concrete, and or a lower cost PCC with more recycled materials or softer, larger aggregate that is used in the mix, since this mix, which is the base mix, is not the wearing surface. So if you go now to the next slide, Wouter. Similarly, the definition for PCC over PCC, this was extracted from the Sharp 2 Research Report, Volume 2. This would be defined as a relatively thin, high-quality concrete surface placed immediately on top of a plastic concrete layer that was placed. And this would be similar to the definition in terms of the mix, the PCC mix that was used for HMA over PCC, new composite pavements. But that PCC mix, since it's not the lower layer, not the higher quality surface layer, but the lower base mix, can consist of higher amounts of different types of recycled, larger, softer, coarse aggregate that might be less suitable for use in a wearing surface. So the wearing surface, relatively thin, and relatively thin for the PCC in the Sharp 2 report was defined as about 3 inches on the average. And I'll get into that a little bit later in the presentation. I'll come back to that relatively thin definition again. So if you go to the next slide, Wouter, please. So we have basically 3 different types of pavement design strategies from 3 different references summarized here. In the MEPDG manual practice, basically a composite pavement was defined as a semi-rigid pavement, which was an AC layer placed over a new cementitious stabilized material. And those materials are noted in this slide in the left column, varying from lime to lean concrete. The column 2, this was the Sharp 2 volume report. This is AC over recently placed PCC itself, and that PCC could consist of a jointed plain concrete or a continuously reinforced concrete layer. The Sharp 2 Volume 2 report could also noted it could also be like lean concrete or roller compacted concrete, as long as there are joints in that layer. The right column, this was the Volume 2, where we have PCC placed over plastic PCC, basically at the same time. And this could be both jointed plain concrete as well as continuously reinforced concrete, with that surface layer being a high quality surface placed over what could be a lower cost PCC base type mix. Go forward, Wouter, please. So there's a distinct difference if we look at the MEPDG manual of practice. I'll also mention this later on in the presentation, but the modulus of rupture for the cementitious stabilized materials is basically capped, or is less than 400 psi at 28 days. It does include cracking, fatigue cracking predictions of that cementitious stabilized layer, but those fatigue calibration factors, the fatigue transfer functions, are different than the conventional PCC mixes that are used in the Sharp 2 Volume 1 and/or Volume 2 reports for those types of new composite pavements. So there is a distinct difference between each category, or how we're defining composite pavements. And I'll try to note that throughout the presentation as we're going through. So for this webinar, we're focusing more on columns 2 and 3, the Sharp 2 Volume 1 and the Sharp 2 Volume 2 reports as they are applied to the Pavement ME Design software itself. So remember two distinct things. The modulus of rupture is generally very low, or less than 400 within the software for cement stabilized base material. And there are different fatigue cracking calibration coefficients in comparison to conventional PCC type mixes that are specific to the Sharp 2 reports for new composite pavements. Go to the next slide, Wouter. And that's just kind of in a pictorial or illustrative to just note that. Semi-rigid pavements within the pavement ME are not the same as new composite pavements with an asphalt surface and or higher quality PCC surface. And that's to show that in this illustration slide shown here. Go to the next slide, Wouter, please. So we have our new composite pavements are defined, and this is the definition that we're using. New asphalt for new composite pavement design. New asphalt layers placed on new or recently placed but hardened PCC base layer. And then the second is new PCC surface placed on new plastic PCC base layer. Within the MEPDG manual of practice and also the software, there is no direct design strategy in the Pavement ME software that considered this specific design strategy of new asphalt layers over new JPC or CRC, or new higher quality PCC mixes placed over new JPC or CRC layers itself. And the semi-rigid pavements is categorized differently from new composite pavements. So, Wouter, go to the next slide, please. There are two, and I mentioned the first edition of the MEPDG Manual of Practice was published in 2008. That was before the Sharp 2 research project. There have been two updates or two additions to the Manual of Practice, one in 2015 and one in 2020. Both of the recent additions regarding composite pavements were not revised. So the sections that I noted at the beginning of the presentation, sections 3.3 and 3.4, are basically the same and do not note a difference between semi-rigid and new composite pavements that we're going over. Wouter, go forward. And the reason for that is adding a new design strategy for new composite pavements. What we're focusing on this morning is on the AASHTOWare Task Force list of future enhancements. And that has been on the list for at least 2 to 3 years. And once the new design strategy of new composite pavements has been authorized by the task force, then to add new composite pavements. Obviously, the manual of practice, the MEPDG manual of practice, will be revised to reflect the specific new pavement design strategies. So go forward. So we're going to move now into using the existing, when I say existing PMED software, that's the latest version, version 2.6. Can we use that version to design and or evaluate new composite pavements as defined using the Sharp 2 research work in volumes 1 and 2 that were published in 2013. And I guess what I would, before we go forward, those that know me, my voice is probably sounds a little bit different or may sound different. I may go silent during the presentation for 1 or 2 seconds, and that's because my 10-month-old granddaughter gave me a cold last week, and so I'm getting over that cold, but I still have a little congestion and stuff like that. So that's one of the reasons why I may go silent for a couple of seconds. Anyway, Buddha, if you would go forward to the next slide. So how do we go forward in using Pavement ME version 2.6 in coordination with the Sharp 2 research report if we as a user want to use the software to design and or evaluate new composite pavements as defined from the Sharp 2 research reports. And so this is obviously not in the manual of practice, but this is a suggested decision tree. And the reason it's not in the manual of practice, just to kind of dwell on this a little while, is this hasn't been reviewed, approved by the task force, the AASHTOWare task force, and or COMP, AASHTO COMP committee. So that's a very formal process that AASHTOWare and the task force use for making decisions on how the software gets enhanced in going forward. These are suggestions predominantly in terms of using the software to design and or evaluate a different design strategy than the software was designed and written specifically when it was originally developed, and or other enhancements have been added over time. The reason, and I should have mentioned this at the very beginning of the webinar, the reason that webinar 3 is being given this fiscal year on new composite pavement design is from the user group meetings of high interest topics, as well as the end of last year on one of the webinars, our webinar 4 in fiscal year 2021, we asked the participants of the webinar what would be of a high interest and gave them different topics. New composite pavements was a very repeated as a very high importance or a topic that the participants either at the user group and or the webinar said that they were interested in. And so the task force decided that we should put together this webinar on new composite pavements. So that's the reason for the topic of this being webinar 3. So now getting back to the decision tree. The decision tree is basically broken out into two surface types, obviously asphalt wearing surface or Portland cement concrete wearing surface. The next would be the base strength, as mentioned earlier. Are we talking about a cementitious stabilized material which has a modulus of rupture generally less than 400 psi at 28 days? versus using what could be defined as a cement stabilized or cementitious stabilized base that has a modulus much greater than 400 psi at 28 days. And then for the PCC surface, a cementitious, the same characterization. The two rows being designated as less than or greater than 400 psi modulus of rupture at 28 days. The base type is broken down into, for the asphalt, as plain and or jointed plain concrete and or continuously reinforced concrete. Obviously, if we have a roller compacted and or lean concrete that has a modulus of rupture much greater than 400 psi 28 days, but without steel, those two base types would fall under jointed plain concrete. And then the third category, if our cementitious stabilized base is a continuously reinforced concrete, whether it is a conventional and or let's say lower cost PCC mix for the CRC layer, that would be defined as such. So the design strategy recommended in the SHORP 2 is for the higher quality where we have a modulus of rupture of 400 psi, 28 days, much higher than that. The JPC would be an asphalt overlay of a JPCP, and for the CRC, asphalt overlay of CRCP. You can see that we have a check or what's a column identified as a check. For the JPC, that would be checking it as a new JPCP, and for the CRC, checking it as a new CRCP. The upper row, that's basically in the MEPDG manual of practice, where the cementitious stabilized base is less than 400 psi at 28 days. That would be a new semi-rigid pavement, and that would be designed in accordance with the MEPDG manual of practice as it exists to date. And there is a specific design strategy for new semi-rigid pavements. For the PCC surface, it's very similar to the asphalt. The design strategy, if we have a cementitious stabilized where the modulus of rupture is less than 400 psi, 28 days, we would design that as a new JPCP or a new CRCP, and that would fit the current design strategy type that's in the MEPDG, and those would be defined in accordance with the current MEPDG manual of practice. If we have a cementitious stabilized layer with a modulus of rupture much greater than 400 psi, then it would be similar to for the asphalt, except that for the JPC, the design strategy would be a bonded PCC overlay of a JPCP, and the CRC would be a bonded PCC overlay of a CRCP. The check would be a new JPCP for JPC type, and then the check for the CRC would be a new CRCP design strategy. And I'll show some examples of by what I mean as a design strategy and check in just a minute. But this is the basic flow chart that we're using. So if you would go to the next slide, Gooder. So we know that anytime we have kind of a difference from what Pavement ME was originally designed and calibrated for, the question of calibration always comes up. Can we use the current, let's current be in version 2.6, for how we're using the software to design and or evaluate a slightly different design strategy. Is it appropriate or is it not appropriate? And so that's what this slide is intended for. For semi-rigid pavements, the version 2.6 was calibrated for asphalt layers over cementitious stabilized base layers. And remember, those are layers where the modulus of rupture is less than 400 psi at 28 days. And it was calibrated for that, so it is appropriate to use version 2.6 to design and or evaluate what's defined as semi-rigid pavements. For AC, for now a new composite pavement in accordance with Volume 1 of the Sharp 2 report, AC over JPC. That design strategy was in fact calibrated for asphalt overlays of JPCP. The calibration, however, was where the JPCP pavement has been in place for some time. And we'll kind of come back to that later on in the presentation. But the calibration factors that are being used are those that were calibrated in version 2.6, and more importantly now, the new calibration that's going to come out in version 3 for AC over JPC. Similarly, AC over CRC, and this would be Volume 1 of the Sharp 2 report. The only difference between AC over JPCP versus AC over CRC from what has been done is there were a lot fewer sections that were used in the calibration of AC overlays of CRCP. But the calibration and the calibration factors that are being used or that should be used would come from the calibration of asphalt overlays of CRCP for the CRC new composite pavements and the calibration factors for JPCP for the new composite pavement JPCP design strategy. Now moving down to the last two items where we have a higher quality PCC placed over a JPC and or a higher quality PCC placed over a CRC type mix. Those have not been calibrated for version 2.6. And we'll get into that in just a minute or when we talk about calibration later on. But I wanted to specifically note that those two design strategies of higher quality mixes over lower qualities or two-lift construction, those have not been specifically calibrated using version 2.6. Wouter, go to the next slide, or the next forwarded. But I want to also make a point that as designers and engineers, including myself, we make assumptions in using design procedures beyond for which they were developed and really calibrated. And I'd like to, also point to the fact that the AASHTOW 93 design guide, is used much beyond for which it was originally developed and or calibrated. And it basically was calibrated by experience and use, which took many, many, many years. So I don't want to say we can't use Pavement ME in the current, let's say, version 2.6 for designing new composite pavement design strategies in accordance with the Sharp 2 research report, two research reports. As long as we understand the assumptions we're making, and as long as we understand the fundamentals behind them, in my opinion, we can use those with appropriate assumptions and ensuring we understand those assumptions. So we're going to focus on assumptions later on in the presentation. So that's the reason I wanted to highlight this at the very beginning. So, Gooder, if you go to the next one, please. So, designing new composite pavements. And the reason I still have the new semi-rigids, both in what we have in the manual of practice today, because of the manual of practice states, those semi-rigid pavements are considered composite pavements. Again, remember the distinguishing feature between what's currently in the MEPDG manual of practice and what's in the SHARP 2 research report. Comes back to the strength of that cementitious stabilized base layer at 28 days. For new semi-rigid pavements, that's limited or is less than 400 psi at 28 days. Whereas SHARP 2, can be much greater. So that's the reason we still have this in here. So this just lists the design strategy, the design criteria. Any of those that used Pavement ME for semi-rigid, you understand and probably have used these. So I'm not going to dwell on them. Good, or go to the next one. And this is just using the current Pavement ME software for designing new semi-rigid pavements. This is the screenshot. Just let's focus on the top 3 items. Chemically stabilized base, fatigue, low transfer efficiency, chemically stabilized base, crack transverse low transfer efficiency, and chemically stabilized base crack spacing. These are no change from what's in the software. Again, as I said earlier, we would use the MEPDG manual of practice in accordance with designing new semi-rigid pavement. So and the 2020 version does include updates that includes the new calibration factors for semi-rigid pavements. That is in the 2020 MEPDG manual of practice on what is the crack spacing, what's the load transfer efficiency, as well as what the other layer properties are, either their default values or how they should be determined. So that's in the manual of practice, and I'm not going to dwell on that. Go to the next slide, Wouter. Now, this is, again, the limit on the modulus of rupture, as noted, it's less than 400. 400 is the cap, and that was used in the calibration itself. Obviously, since we have a CRC layer, and that includes steel, we cannot use semi-rigid pavements for the CRC because we can't simulate steel in the MEPDG for that cementitious stabilized base layer. So go to the next slide. So now moving to the SHARP 2, new definition, new composite pavements. This is HMA over PCC. Remember, the design strategy is AC overlay. So we have an AC over a JPCP for AC over JPC, or AC over roller compacted concrete, lean PCC base, because those can generally have a modulus of rupture much greater than 400 psi at 28 days. AC over CRCP would be used for AC over CRC. And this shows the design criteria that was recommended, the parameters to be used in the SHARP 2 report. AC over JPCP, rut depth, PCC transverse, or crack slab, NIRI. Those that have used the software for rehabilitating, like an asphalt over an existing JPCP in place, there are many other design criteria that can be used. And we'll get into those differences a little bit later. The second is AC over CRCP. Again, the design criteria: rut depth, punch outs, and IRI. Similarly, those that have used the software design asphalt overlay of existing CRCP, there are many other design criteria that you can use for designing an overlay of CRCP. And also, we'll note those later on. Go to the next slide, Booter, please. And now this is PCC over PCC. In other words, the Sharp 2 Volume 2 report. The design strategy here is bonded PCC overlay, if you remember from the decision tree. One is bonded PCC over JPCP for when we have JPCP, and then for the CRCP, it's bonded PCC over CRCP. The design criteria also shown if we had a bonded PCC over JPCP. We have PCC transverse or crack slabs and IRI. And then for the CRC, we have punch outs and IRI itself. Go to the next slide, Victor. So this is the Sharp 2, and this is a screenshot of some of the JPCP design features. And these are basically the same for the HMA over JPCP and or PCC over JPC. So those are basically the same. PCC mix and layer properties for the existing layer are the same as for new JPCP. That doesn't change. So go to the next slide, Victor. And this is for the volume 2, still volume 1, but for CRC, as well as volume 2 for PCC over CRC. And the same statements are applicable for the CRCP as for JPCP design. Those are the same design features. The PCC mix layer properties are the same as for a new CRCP. But you might be asking, okay, especially for the AC over CRC, the PCC over the CRC, we really don't have any steel. If you remember the definition that we gave earlier, in the higher quality, because it's a very relatively thin layer in the wearing surface that's placed on the plastic PCC lower layer. And I will come back to that in a minute. We're going to focus on that item shortly. So, Luder, go to the next slide, please. So this is a summary of the design criteria that I mentioned in the current version 2.6. One for new semi-rigid pavements, one for an asphalt overlay design of JPCP, an existing pavement, and then the lower one, asphalt overlay of an existing CRCP. Those are kind of hard to see, so if you go to the next slide, Booter, and they're just screenshots. This is a summary of the tables, or a summary of the screenshots shown on the previous slide. And so the left column is the criteria, where we have all the different criteria that are in version 2.6 relative to the type of pavement. And then the next column is the MEPDG manual of practice for new semi-rigid pavements. The next column is the Sharp 2 AC over a JPC layer. And then the last column, to show up to AC over a CRC layer. And it notes which of those criteria are used for each of the different pavement design strategies. Focusing on the first highlighted, that's AC total transverse cracking. That's predicted for semi-rigid or the AC over JPC. It's highlighted for AC over CRCP. It's related no with the calibration question mark. The reason for doing that is there were relatively few sections that were used in the actual calibration. And in my opinion, there were really too few to really get I'm going to say an accurate, or let me use the word reliable, prediction, or that's really a wrong term. I guess the term that would be used is something that we could hang our hat on, where we have more sections where we feel comfortable in using. There were really not that many sections. Excuse me, just for a second. There are really too few sections that I would feel comfortable in basing a formal design on transverse cracking of AC over CRC. And so that's the reason that's highlighted. If we go to the bottom of the table, if we go to the bottom of the table, we say mid-slab cracking, faulting, and punch-outs. None of those are predicted on semi-rigid. What is predicted is fatigue of chemically stabilized layers. If we go to the next column, there's only one, faulting of JPC. And that is not predicted for AC over JPC. Mid-slab is predicted for AC over JPC, and punch-outs are predicted for AC over CRC. So I'll come back to these with the no's in just a minute, especially AC over JPCP. Next slide, Booter. So what about faulting in the AC over JPC composite pavement strategy? Also, what about the reinforcing steel that's placed in the lower low-cost layer and not in the thinner, higher quality PCC layer of the PCC over CRC composite pavements? Go ahead and forward it. So to check for faulting, since that's not predicted by AC over JPCP, we would run a new JPCP with the same layer properties of the JPC layer and basically just remove the asphalt wearing surface to ensure that the faulting would be lower than our threshold value, whatever that threshold value is. So we're just ensuring that faulting is not going to be an issue. Go forward again. For the second one, we would complete the PCC CRC design by running a new CRCP with whatever properties are on the lower CRC layer with the reinforcing steel identified at the design depth in accordance with the MEPDG manual of practice or the agency's local design practice. So go to the next slide, Victor, please. The other item, what I want to note is for designing new composite pavements, is the optimization feature for AC overlays of a JPC or a CRC. The optimization feature is only applicable to the asphalt overlay thickness. So if we want to optimize our new composite pavement design using the thickness of the JPC or the CRC layer, which would be suggested, that would have to be done with manual iterations. So if you're trying to use the optimization feature in the software, it's only going to allow you for the overlay, whether it's an AC or a PCC. And the reason for that, the software is assuming that the thickness of that base layer is there and it's known to be the average thickness for the project, which would not be the case for new composite pavement design. That optimization feature would be updated if we have a new composite pavement design strategy after the task force approves that. Go to the next slide. So now let's move on to assumptions and inputs. Go to the next one. So I'm now going to go through those that will be different and how we would handle those between the definition of the SHORP 2 research report on using it as a design versus using the Pavement ME software for the design strategies of an asphalt overlay of a JPC or a CRC, or a bonded PCC overlay of a JPCP or a CRCP. So our first assumption is dates, construction dates. And the assumption is because the software requires a minimum of at least 1 year difference between the existing construction date and when the asphalt or PCC overlay was placed. So the assumption is the year plus offset required by the software has an insignificant impact on the predicted distresses itself. I think that's a reasonable assumption in my opinion. And we'll get into why that's the case down the road. But we're basically assuming that the existing CRC or JPC layers have no to nil damage when the asphalt overlay is placed, or PCC, bonded PCC overlay is placed. That's the assumption. So I think that, in my opinion, I would be comfortable with assuming an insignificant impact on the predicted distresses. Go to the next slide. Other assumption, bond, and this is an assumption that we may not feel very comfortable with. The bond between AC and PCC layers. The assumption is, and that's shown in the screenshot here, is especially if it's an asphalt overlay of a PCC, either a JPCP or a CRCP, the software allows you to say, we got full bond or no bond, but that's at the time of construction. So our assumption to start with is fully bonded. The AC layers will, and our assumption is the AC layers will remain bonded to the underlying PCC layer throughout the design period. Is that a reasonable an assumption? Go forward, Bruder. Yeah. So the designer and engineer needs to decide if that assumption is appropriate. Especially if we're talking about relatively thin asphalt layers. will that bond last over the design period? The design period is 20 years or what, whatever it is, 20, 25 years or whatever. But that's the assumption we have to make. Now, we can, in design, let's say if we think, okay, based on my experience, I think that this bond is, we're going to lose bond 10 or 15 years down the road. That still could be simulated in the Pavement ME software, but it would be at the time of construction. And so you would look at the interface friction of being zero between the flexible and whatever, if it's a CRC layer or a JPC layer, that would be simulated as zero. But that's going to result in a lot of distress. And if I think I'm going to lose bond, then I'm not sure I would design a new composite pavement or design it assuming I'm going to mill it and remove and replace the wearing surface of whenever I think that the bond may be lost for whatever reason. But that's the assumption we're going to make, and we must understand what that assumption means. Go to the next one. Okay, assumption also is that all asphalt, PCC, unbound, aggregate base layer, subgrade properties, layer properties are the same as for a new flexible and a new rigid pavement design layers. The actual material properties are going to be the same. And I think this is a reasonable assumption, in my opinion. Go to the next. Reason for that, if we look at because this is let's say an asphalt overlay over a CRCP. So for the CRCP rehabilitation, we're assuming or entering 0 punch outs per mile at the beginning of the design. So we're assuming minimal or nil damage in the CRCP layer. Similarly, the CRC foundation support, the modulus of subgrade reaction is being calculated itself. There's no deflection data because we don't on the CRC pavement to actually maybe calculate that modulus of subgrade reaction from deflection measurements because the layer hadn't been placed yet. So that's going to be calculated by the software shown in the screenshot here. Go to the next slide. So for JPCP rehabilitation, we're assuming 0 slabs distressed replaced before restoration, 0 slabs replaced after restoration. And similarly, for the JPCP foundation, the modulus of subgrade reaction is being calculated by the program. Go to the next slide. This is one of the big assumptions, and this is a couple of reasons why I highlighted in front of the tables previously, or highlighted some of the columns. Our assumption is that the asphalt and PCC calibration coefficients derived for new flexible and rigid pavements as well as for asphalt overlays of PCC pavements are applicable to new composite pavement design strategies. I want to make a point now here that, remember, the semi-rigid pavements have been calibrated, and that's asphalt over cementitious stabilized base sections where the modulus of rupture is less than about 400 psi at 28 days. That has been calibrated. This is specific to the new composite pavement design strategy in accordance with the SHARP 2 reports. So the asphalt, new asphalt, the overlays, and the PCC calibration coefficients are applicable, but rutting calibration, fatigue cracking calibrations are applicable for asphalt overlays of PCC pavements to new composite pavement design strategy. For forward Yes, if you would forward, so the designer and engineer basically needs to decide, is this assumption appropriate? And as I said earlier, in my opinion, which I have designed and evaluated new composite pavements in accordance with the SHARP 2 research reports, I would feel comfortable making this assumptions for asphalt overlays of PCC layers. If we're talking about new PCC layers placed over PCC plastic mix for the new composite pavement strategy in volume 2, I would feel less comfortable about that. And you'll see what we can do when I get through an example later on. Okay, go to the next slide. So now we're going to quickly go through some examples. So the next slide, Gunnar. And I'm going to go through kind of each one relatively quickly to indicate how the software, existing version 2.6 software, could be used. I'm kind of using an existing section or a pavement that exists in the Southwest, or climates in the Southwest. It's an agency that has a lot of experience with placing asphalt over JPCP, and that AC is basically used for noise control and protecting the JPCP or the JPC surface, and has done this for more than just a few years. It's relatively heavy trucks, 20-year design, and the total number of trucks is 16 million. The axle load distribution in the Pavement ME, using Pavement ME, would be a heavy load distribution, or characterized as heavy load distribution. So kind of to give you a sense in terms of equivalent single axle loads, this would be somewhere similar to about 35 to 40 million easels over the design period. But it's 16 million trucks over the design period of 20 years. And this is AC over JPCP. And so this is just a screenshot of using the software where it's asphalt overlay over an existing 1 year existing JPCP. Next slide, Vitter. And so we had used 3 inches. Oh, I'm sorry, Vitter. Go back to the next slide. Yeah. The structure was 3 inches of an asphalt wearing surface, so it's more than just noise control, over 8 inches of a JPC base, and then 9 inches over a crushed stone base. And the existing soil is an A4 soil. So the soil is pretty good. And we have a very good, higher quality crushed stone base. Next slide, Vitter. Okay, and this is the output report. Using the properties, the standard calibrated properties for the asphalt, overlays, new asphalt mix, using the Socrates that have been calibrated for a JPCP pavement, using that as is. This is the output report. And you can see the terminal IRI shown, permanent deformation for the asphalt layer, AC bottom-up fatigue cracking, AC thermal cracks, new, that's new, AC top-down fatigue cracking, and JPCP transverse cracking %, which is very low. What's really not shown is the total transverse crack, new, that's shown on the screenshot, plus the reflective cracks. those will exceed, almost always exceed, like 1,500 feet per mile. And I'll come back to that in just a minute. But if you're using an AC over a JPCP existing, those reflection of the joints are typically going to be greater than 1,515 feet per mile, or 1,500 feet per mile. That's typically used as a threshold value. So go to the next. This just shows the top-down cracking for the new composite pavement of AC over JPC. You can see here that the amount of cracks is very low, and those cracks that do develop, they do not propagate through the entire asphalt overlay layer. But this is available. This is in the output report for version 2.6. Next slide, Bruder. This is the check. Remember the check? So remember, we didn't calculate it. The program does not calculate faulting. But we know that faulting still may be an issue of an asphalt overlay of an existing jointed plain concrete pavement. So for our design, will the pavement fault or will it not? And the category I used would be used in this design is highly erosion susceptible, or a number, I think it was a 4 or 5, susceptible to erosion. So what the designer would do, or what was done, is to use the new JPCP of the existing, or for the JPC layer, all the same properties, but assume that that layer, we're going to design it for faulting, or to ensure that it's not going to fault. And so the table at the bottom just shows that using the optimization feature for faulting, as well as transverse cracks, that a new JPC layer of 8.5 inches over 9-inch crushed stone would satisfy the traffic over 20 years. Our design strategy we used was 3-inch asphalt over 8 inches of JPCP over 9 inches. And so at 8 inches, the faulting was still less than 0.12 inches. And so the trigger was the cracking. And so we would be, if I was doing this design, would be relatively confident that if I built 3 inches over 8 inches over 9 inches as my pavement structure, my faulting is not going to exceed at a 90% reliability level that 0.12 inches threshold. So basically used a new JPCP design strategy to ensure we're not going to exceed the faulting criteria. Go to the next slide. This is AC over CRCP. Same thing as on the previous run. The only difference is now we have a 3-inch asphalt wearing surface over an 8-inch CRC layer, over 9 inches crushed stone. Next slide, Vuder. So this is now our put report. And as you can see, that we have our terminal IRI, permanent deformation in the AC bottom-up fatigue cracks in the asphalt overlay, AC top-down fatigue cracks in the asphalt overlay, and then the CRCP punch-outs predicted over the 20 years. Two notes, similar to the JPCP. Total transverse cracks, new and reflective, will exceed the typical threshold value used of 1,500 feet per mile. Typically going to be greater than that. The other note, I'm going to come back to that highlighted item I noted towards the beginning of this section. Insufficient number of asphalt overlay of CRCP sections to calibrate or feel comfortable in the calibration of total transverse cracking predictions itself. So considering those two, go to the next slide. This just shows top-down cracking again over the CRC. Again, similar results predicted for the JPCP. We do have minimal fatigue cracks, top-down fatigue cracks predicted. Those cracks do not propagate through the entire asphalt overlay. Go to the next slide. Composite pavement, AC over CRC. The one item that we do get for CRC designs is, and I suggest, or it would be recommended that users using the design strategy do look at crack width over time and the load transfer efficiency degradation over time in the CRC layer. As shown in the screen captures from the Pavement ME output report that are provided. So this provides added information on if we do get a lot of transverse cracks, is it because we're losing load transfer efficiency in the CRC layer, and is our crack widths opening? You can see on the upper graph that our average crack spacing at the end of the design life is already down to 32 inches, which is fairly low. So go to the next slide. And this is just an example. Next one is AC over our check, AC over CRC. How do we check it? And so we would do the same thing as for CRC, or the JPC that we just completed. We just run the CRC as a new CRCP design strategy, removing the AC overlay to ensure all distresses are lower than the threshold value. And that's the terminal as well as the CRC punch-outs. So if we do that, we still are satisfied, but at a thicker overlay layer, or thicker CRC layer thickness, which is shown in the bottom table. And go back to the next slide, Booter, please. One before that, I'm sorry. The one before, there you go. And if you look at CRC punch-outs, it's 18.5 per punch-outs per mile. So that's 18.5. Okay, go to the next one, Booter, now. Go to the next one, and go to the next one. And that's greater than, so if we used 8 inches and remove the asphalt layer, in other words, doing a new CRCP design of 8 inches, the number of punch-outs exceed 30 punch-outs per mile. So if we had just a new CRCP, we would require 9 inches of CRC over 9 inches of crushed stone to have the punch-outs less than 30 punch-outs per mile. And so a designer needs to make a decision and ensure that the AC overlay of an existing CRC is going to be adequate. There are, again, much fewer AC over CRCP that were used in calibration, so that would be something a designer would have to consider. If I was doing the design, I would feel comfortable and say the calibration factors for the CRCP, whether it's new or whether it's under the AC layer, are adequate. And I would be willing to make that assumption personally. But each designer or engineer has to make their own, has to be comfortable with making that assumption. Go to the next one, Booter, please. Now this, getting close to the end, this is the bonded PCC over a JPCP. Basically everything's the same with the exception we're doing a bonded PCC over a JPCP layer over a crushed stone base over a A4 soil. And we're starting with 4 inches high quality PCC mix. That's greater than if you look in the Sharp 2 report, volume 2, where generally about 3 inches is typically, I think, was the norm. 4 inches is the absolute minimum that can be used with the Pavement ME software. And then 5 inches of a JPC base, well, a lower cost base, 10 inches crushed stone. Go to the next one, Booter. And then this is simply the output report. Terminal IRI, mean joint faulting, which is predicted, and JPCP transverse cracking as predicted. Kind of a note, high quality PCC mix placed on a newly placed JPCP, conventional over a low cost PCC mix is not calibrated in any of the global calibrations. So we're making an assumption that the calibration for new JPCP and or the calibrated JPC over an existing JPCP would be applicable to this pavement structure. So go to the next slide, Vitter, please. And this shows now one thing that I would suggest everyone look at, bonded PCC over JPCP, is we have in the output report a look at low transfer efficiency over time and then cumulative damage. The reason for looking at the cumulative damage is it gives you a sense on, are my cracks top down or are they bottom up? In this case, most of the damage is in bottom up cracking, much less damage is in the top down cracking. And so they would be bottom up cracks, which would give me higher confidence in the design. Because that's where my lower quality mix is placed. Go to the next slide. Now, composite pavements, bonded PCC over JPC. Again, the check. This would be running a new JPCP design strategy and checking the distresses. And in this case, we have a higher quality 4 inches over a lower quality mix, lower strengths, 4.5 inches. I should have mentioned that. The lower quality, I used a much lower strength, but it's still greater than 400 PSI at 28 days. I think it was 650 PSI at 28 days versus a higher quality surface mix was about, I think it was 728 PSI at 28 days. For the new JPC, I assume it's all lower quality. So if it was all lower quality, you'd need a 1/2 inch more. And so the designer needs to make a decision, is this 8.5 inches with the higher quality over about the lower half quality, will I still meet my design criteria or threshold values at a 90% reliability? My opinion, the answer to that for me would be yes. Because at only a 1/2 inch, that lower quality would then be satisfied. Using the mix, lower quality mix, full depth would be satisfied. Better go to the next slide, please. This is bonded PCC over CRC. Basically the same example, but using PCC, bonded PCC over the lower quality CRC. Next slide, Booter. This shows the output report, screenshot of the output report. Reinforcing steel is placed in the lower low-cost layer, not in the upper layer. Pavement ME typically assumes it's in the upper layer, so that's a big, big difference. Note the high-quality PCC mix placed on a newly placed CRC or lower quality mix was not included in any of the calibration. Go to the next one, Vooter. Again, this is the check where I'm assuming the new CRCP, everything is on the lower end where the steel is. That would require 10.5 inches as opposed to the PCC over the CRC, higher quality of 4 inches, using the lower quality of 5 inches. Program would say it would satisfy, but for using the lower quality, it says we need 10.5 inches of all lower quality materials versus 9.5 inches of higher quality and lower quality materials. This would be the big assumption on the designer. So I'm going to come back to this in just a minute. Go to the next slide, Vooter. And I want to get away to our takeaways and assumptions. I'm probably going to go over wanted to try to limit this less than an hour and a half. I'm probably going to go over that just a little. Go to the next one. So I want to focus now engineering and make sure everyone understands engineering judgment is needed, especially in separating new semi-rigids from new composite pavements. There is a decision tree or a definitive how we make that judgment decision through the software. Is that applicable to agencies' design specifications? And semi-rigid pavements are different from new composite pavements. Go to the next one. This is the decision tree. And you can see that we started the same decision tree that we started with. The difference, the big difference. As for the CRC, the design strategy of bonded PCC overlay of the CRCP. Have that highlighted and I have it crossed out. The reason for that, software assumes there's going to be steel in the bonded overlay, which is not the case. So in that case, the check would really be the design using a new CRCP. The decision the designer has to make for those thickness differences is that thinner pavement still adequate for assuming, where we have high quality and lower quality materials versus assuming we have lower quality. What's the difference? And each designer, if they're using that, will have to make that decision. I would not use the bonded PCC overlay of the CRC because of the differences in the steel. And so I would rely on simply doing a new CRCP and then make a decision on what is the value of that higher quality material. I'll go to the next slide, Vooter. Calibration coefficients for new semi-rigid pavements. That's in Pavement ME, it's in the software, it was calibrated, so do it in accordance with the Pavement ME manual practice. Next slide, Vooter. This is calibration coefficients for new composite pavements. The one on the left, AC overlays of rigid pavements. They have been calibrated. Go forward, Vooter. Use AC overlay of JCP or CRC calibration coefficients. My opinion is I would be comfortable making that assumption or using those calibration coefficients. The one on the right, PCC high quality mix, higher quality PCC mixes over lower cost PCC mixes has not been calibrated. Forward it. Use new JPC or CRCP calibration coefficients. I definitely still would be comfortable using those new calibration coefficients for the new pavements, as well as the bonded PCC over the JPCP. Go to the next one, Booter. Minimum wearing surface defined by the agency's design policy. Always remember what the minimum layer thicknesses are required, not only through Pavement ME, but also the local agency's design policies. Those are very important. Minimum thickness required by the software, PCC wearing surface is 4 inches. Go to the next. I'm sorry, yeah, that's it. So new AC over JPC, use AC overlay of JPCP strategy. Remember the AC overlay date is 1+ years from the JPC construction date. Determine the JPC layer thickness, excluding transverse reflection cracks. Use the JPCP design strategy to ensure faulting is less than the threshold value. Next slide. Note that using the new JPCP strategy, credit is not really given to the AC over the AC wearing surface. Next slide. AC over JPCP. Just as I mentioned, saw and seal is a very appropriate strategy, even for new composite pavements, where you're sawing and sealing joints in the asphalt layer above the joints in the JPCP section. Next slide. AC over CRCP, use the AC overlay of CRCP, very similar to the JPC one. Asphalt overlay date, 1+ years after CRC construction date. Determine CRC layer thickness, use the CRC new design strategy to ensure all the stresses are less than the threshold values. Next slide, or go forward. Using the new CRC strategy, credit is not given to the AC wearing surface. Next slide. PCC over JPCP composite pavement. Use bonded PCC overlay of JPCP. PCC overlay is 1+ years from the JPC construction date. Determine layer thickness of lower cost JPC layer. Use the new JPC with the lower cost JPC layer to check and ensure faulting is less than the threshold value. Go forward. Using the new JPC design strategy, full credit would not be given to the higher quality PCC, bonded higher quality PCC surface layer. Next slide. This is the PCC, bonded PCC over CRC. You can see that I have the first 3 crossed out, and that based on that decision tree highlighted section. And what I basically go forward, Booter, is these are suggestions from the Sharp 2 Volume 2 report, but there's no steel in the PCC wearing surface that's simulated in the Pavement ME. So I would just use the CRCP new design strategy to check and ensure all the stresses are less than the threshold values. Go forward. And just remember, for the new CRCP section, using the lower quality properties of the lower layer, we're not giving any credit for the higher quality PCC wearing surface. So a designer has to ensure, from a thickness standpoint, what's the effect of that higher quality wearing surface. Go to the next slide. And remember, for the PMED software, overlay designs are suggested for new composite pavement design. The optimization tool is only applicable to the overlay itself. optimization of the new JPC or CRC layer is done manually. Go to the next slide, please. So, Footer, let's go to the question and answer, and then try to answer as many questions as we have. I did go over the limit I wanted to try to limit this to, but I think that's because I couldn't talk for a while.
Sure. Did we want to do the poll now or afterwards?
No, do the poll now.
Okay. Sounds good. All right, so I'll start poll 2. I put 3 minutes for it. So I'll open that up.
Also, Footer, were you able to answer many of the questions or some of the questions that came in?
I wasn't, just because I was making sure I click on the right times and all that.
Oh, I'm sorry.
There weren't many. There's been,
okay,
I think, 3 so far.
that's right. Yeah, you were doing the slides.
Did we want to start those or wait until the poll's over?
I would say go ahead and start it.
Okay. So the first question is from Millen, and it's, if the existing PCC JPCP layer is damaged or have cracks developed along with raveling, what treatment shall be given prior to overlay with AC or JPCP to obtain the assumed bond?
Okay. Okay, that's on a different topic, because we're not talking, this webinar is not relating to, or was not focused on existing layers with damage. This was focused on existing layers with no damage or nil damage, because we're starting the design period almost right after those materials were placed. So there is no raveling and there is no cracking in the JPC or CRC layers, other than the cracking that would be normally anticipated in a CRC layer, and or maybe shrinkage cracks in JPC layer if that happened. But to answer the question is, if there is damage and we're talking about an asphalt overlay of an existing JPC and or CRC layer, because that's then I would do a grinding on the surface. There's cracking. The standard, in accordance with the MEPDG manual of practice on how to treat the existing surface prior to restoration or rehabilitation of the surface, and or the local agency's standard day-to-day practice for treating those distresses. I hope that answers the question.
Get it. The next one here is similar, also more related to overlay designs. Can we design and lay JPCP over JPCP when the old pavement is more than 15 years old? with no bond in between. My suggestion is also this is more of a JPCP unbonded overlay design strategy.
The answer to that question would be yes, you can. And those rehabilitation design strategies should be done in accordance with the existing MEPDG manual of practice and or existing agencies' standard day-to-day practices. So yes, you could use the software.
Okay, and the next one came through the chat. The manual practice provides higher subgrade MR for AC than JPCP pavements. Should not subgrade MR be as specified for JPCP or AC over JPCP composite? So which subgrade modular value should be used based on this design?
Okay, maybe would you? I'm not sure I understood the question. I thought you said modulus of rupture. Would you refer to the question again?
Yeah, so it's the manual practice provide higher subgrade resilient modulus for AC to JPCP payments. I think it's one of the tables where it suggests the resilient modulus for level 3. And then which value should be applied for new JPC or for the new composite payments versus just a new JPC?
Yeah. If you have an asphalt overlay of an existing, or if you have a new design, rigid versus flexible, you should use, in terms of a new composite pavement design strategy, use the subgrade resilient modulus that is appropriate for the pavement structure. So there is, if you do that in accordance with the MEPDG manual of practice, it's appropriate for the stress sensitivities that exist under that composite pavement. Under that composite pavement, the stresses in the subgrade are driven predominantly by the concrete layer. In other words, the stresses, or not the stresses, the stresses will be relatively minimum or low. It's the overburden point of control. So you would use the resilient modulus that's more appropriate for the concrete rather than an asphalt section. I hope that answered the question. But that would be in accordance with the MEPDG manual of practice. Next one.
That's it.
Oh, good.
Yeah.
Okay. Do we want to open it up for other questions?
We can.
That would be up. I'll leave that up to Clark and Ryan.
So I think we can take just a minute to see if any other questions come up. And if not, I think we should probably wrap things up.
Sounds good. Okay.
Okay, just a few announcements before we wrap up. First off, thanks to everyone for attending. We appreciate your time. We do have one more webinar in this fiscal year, and that will take place on June 22nd, 2022, this year. And that is on Introduction to the new web-based version 3.0. And we're all in the task force really excited about version 3.0. I'd really encourage you to attend. I think this will be a huge improvement for our software. Okay, next slide. And we just have some contact information here. You see the contact information for Ryan Fragapane, our AASHTOWare project manager, and my email address is there as well. Feel free to send questions or comments about the webinar or the Pavement ME program to either one of those. I would put out the ME Design resource website, www.me-design.com. And all of our webinars are posted there, and you'll be able to see that one posted. Today's webinar will be posted there shortly. The user group contact is Jennifer Albert with FHWA, and Jennifer's email address is there. For support in using the Pavement ME software, our help desk contact information is there. The email address, pavementmedesign@ara.com. You can also call the phone number 217-356-4500. And we also have email addresses for other ARA staff who are involved in support of the Pavement ME Design software. And with that, thanks everyone for coming. We appreciate your time.